Welcome back to The Explainer. If you're an 8th grade scientific detective, or honestly just someone who loves getting to the absolute bottom of how the world really works, you are in exactly the right place today. We're throwing on our lab coats, grabbing our magnifying glasses, and going on a mission to uncover the hidden, true causes behind everyday events. If you've ever wondered why certain things happen or how you can actually control the outcomes in your own life, stick around. We're going to bring some serious energy today as we unpack the systems and models in science that literally shape our reality. So, before we jump into the lab, let's look at the foundational framework this source material gives us for our investigation today. This is a quote from Job chapter 4, verse 8, and it perfectly captures a massive cosmic principle: actions and consequences. It's that ancient idea of sowing and reaping. I mean, think about it. What you put into the dirt is exactly what grows out of it, right? If you sow trouble, you reap trouble. According to our source, this isn't just an old proverb, it's actually the ultimate, earliest description of the scientific law of cause and effect.
And here's our quick roadmap for today's explainer. First, the science of why. Second, defining cause and effect. Third, the correlation trap. Fourth, testing like a scientist. And finally, smart minds, good choices. Let's get to it.
Section 1. The Science of Why. To be a great investigator, you have to start by asking the big question. Why is it so critical to find the real reasons behind why things happen? Well, here's exactly why it matters. Understanding cause and effect relationships is basically a superpower. It lets scientists explain why things happen, and even better, it shows them how to control those outcomes. Think about a farmer managing their irrigation. Knowing for a fact that a lack of water causes plants to wilt allows them to take immediate action and save their entire crop. If we don't identify the true cause of a problem, we end up jumping to completely wrong conclusions. And making wrong conclusions, whether you're in a science lab or just living your daily life, can waste your valuable time, drain your hard-earned money, or even lead to serious harm. Moving right along to Section 2, Defining Cause and Effect. Let's open up our scientific toolkit and get our core concepts crystal clear. We need to completely separate these two ideas in our minds. The cause is simply what makes something happen. It's the trigger, the spark, the initial push. The effect, on the other hand, is what happens as a direct result. One directly, absolutely leads to the other. Think of a line of dominoes. If you reach out and push that first domino, your push is the cause. The domino actually falling over, that is the effect. Let's break down some real-world examples to really cement this. For instance, when the cause is giving a plant more sunlight, the effect is that the plant grows taller. Why? Because sunlight provides the energy for photosynthesis, which directly impacts the plant's growth. It's a true, undeniable cause and effect relationship. Similarly, if the cause is long-term smoking, the effect is reduced lung capacity and lung disease, because the specific chemicals in cigarette smoke actively damage human lung tissue. These aren't just random guesses. They are concrete, observable examples of how a highly specific cause produces a highly specific effect. So, the absolutely crucial point here is being able to spot this out in the wild. Let's do a quick knowledge check based on your homework from the source material. Here's a scenario. Fertilizing plants made them grow faster. Pause for just a second. Which part is the cause and which part is the effect? Well, if you said that adding the fertilizer is the cause and the faster growth is the effect, you totally nailed it. You're thinking exactly like a scientist right now. Now for Section 3, the correlation trap. We are about to uncover a massive trickster that fools a whole lot of people every single day. Take a look at this slightly silly, but honestly highly revealing question. Does eating ice cream make it hot outside? Now, if you look at the raw data, it actually shows that when ice cream sales go way up, the temperature outside is also really high. They happen at the exact same time. So, what's the conclusion? Should we ban ice cream sales to stop summer heat waves? Obviously not, right? And this perfectly illustrates our next major concept, correlation. Correlation is simply when two things happen together, but one doesn't actually cause the other. While ice cream sales and hot weather happen at the same time, eating a chocolate cone doesn't somehow cause the sun to shine brighter. The real cause is the weather. The intense heat makes people feel hot, which leads to the effect of buying more ice cream. Mistaking a simple correlation for true causation is a massive trap that can completely derail any scientific investigation. All right, Section 4, Testing like a Scientist. How do scientists actually isolate the real truth so they aren't fooled by simple coincidences and correlations? Well, they use a highly structured process. Think of it kind of like tweaking a recipe step by step. Step 1, change one variable. Now, a variable is just a fancy science word for a factor you can change, like the exact amount of water you give a plant. Step 2, observe the impact of that specific change. And step 3, use repeated trials. You don't just do it one time and call it a day. You do it over and over again under tightly controlled conditions. Let's spark a little interactivity here. Looking at those 3 steps, why do you think changing just one variable at a time is the absolute most important rule in our entire scientific investigation? Think about it. What happens if you change the water, the sunlight, and the soil all at the exact same time? Exactly. You test one variable at a time to know exactly which change caused the effect. If a plant suddenly shoots up 3 feet taller, but you change the soil, the water, and the sunlight all at once, you have absolutely no idea which of those 3 things actually did the trick. Isolating a single variable is literally the only way to be 100% certain of the true hidden cause. Let's throw out another really engaging homework question from the source material to make sure we're firmly grasping how scientists double-check their work. Why do we bother with step 3? Why are repeated trials so incredibly important in proving cause and effect? Why not just test your plant once, see it grow, and publish your results? You repeat the trials to prove the result wasn't just some random coincidence. Maybe the plant just had a really good week. Maybe some random insect helped it out when you weren't looking. By running repeated trials in controlled experiments, scientists confirm that the relationship is a consistent, reliable law of nature, not just a fluke or a correlation trap. This is how actual scientific proof is firmly established. And finally, Section 5, Smart Minds, Good Choices. Let's zoom out here to see how the source material applies these tools to a much broader life philosophy. The source material actively connects these hard scientific principles of cause and effect to our spiritual well-being, sharing this promise from Romans 8, 6-7. It outlines 2 very distinct causes and their resulting effects. According to the text, a mind governed by the flesh causes an effect of death, but the cause of keeping a spiritually focused mind leads to the ultimate positive effect, life and peace. It's a really interesting way the text illustrates the profound consequences of where we actually focus our thoughts. And that brings us to the core philosophy outlined in the HeroesmartAcademy Godly Learners series. They firmly intertwine biblical morality with education because, as they state right here, education without morality will hurt. This philosophy argues that scientific smarts and understanding the mechanics of the world really must be paired with moral wisdom. Just like testing variables in a controlled lab, the variables we introduce into our own personal lives have guaranteed predictable impacts. Which leaves us with this incredibly powerful, provocative thought to wrap up today's explainer. Based on everything we've just learned about the strict, undeniable laws of cause and effect, what is the point of being incredibly smart and highly educated if you continue to make bad choices that hurt you? I want you to deeply consider how the science of true causes and undeniable effects applies directly to the variables you're controlling in your own life today. Thank you so much for joining me on this explainer. Keep asking why, keep testing your variables, and I'll catch you next time.